Good morning, all. Welcome to 6-day FDP on emerging trends in GIS and artificial intelligence for civil engineering. We will start our session within 5 minutes. We are waiting for the resource person to join.
Good morning, all. Today's topic is Geospatial Applications in Flood and Landslide Susceptibility Mapping by Dr. K. Srinivasan. It's my pleasure to introduce today's distinguished resource person, Dr. K. Srinivasan, Assistant Professor in the Department of Forest Resource Management and Head of the Department of Remote Sensing and GIS at Kerala Agricultural University, Vellanikara, Thrissur. Dr. Srinivasan has over 17 years of experience in teaching research and geospatial applications. He holds a PhD in Natural Resource Management from Kerala Agricultural University and has also earned master's degrees from renowned international institutions, including Bangor University, UK, and the Technical University of Dresden, Germany. He was awarded the prestigious Erasmus Mundus Scholarship for his higher studies in sustainable tropical forestry. His research expertise spans remote sensing, GIS, climate change modeling, natural resource management, forest ecology, urban heat island studies, flood susceptibility mapping, and geospatial technologies. He has successfully led and contributed to several funded research projects and has published numerous research papers. Dr. Srinivasan is a life member of the Indian Society of Remote Sensing and the Indian Ecological Society. He has coordinated several ISRO, IIRS outreach programs and has actively contributed to capacity building in geospatial technologies through workshops and training programs. With his extensive academic experience and practical expertise in remote sensing and GIS applications, we are privileged to have him with us today. On behalf of the Department of Civil Engineering, Sripati Institute of Management and Technology, I extend a warm welcome to Dr. K. Srinivasan and thank him for accepting our invitation to share his valuable knowledge and insights with us. So please join me in welcoming Dr. K. Srinivasan. I hand over the session to you, sir.
Hello. Hello.
Yes, sir. We can start our session.
One second.
Welcome to MC Music World. Bluetooth mode.
Hello.
Yes, sir.
Hello. Yeah, sorry, there was some technical issues. Uh, Thank you, ma'am. Thank you for your warm welcome. And my topic of present is the slides are visible. Is it visible now?
Yes, sir. Now it is visible.
Okay, okay, okay. So, uh, my topic of presentation. Can I start, ma'am?
Yes, sir, we can start.
Okay, okay, okay. So my topic of presentation, you all might be aware of this geospatial application, which is nothing but this combo of remote sensing satellite as means either an airborne means aerial platforms or terrestrial platforms or spatial platforms, and its interpretation through GIS and means a combination of means through GPS, and all this is a geomatics, is geospatial application of the beautiful technology. Nowadays, it is widely used in A to Z of means disciplines, and it is very helpful in the policy and decision makings. And my topic of presentation, as these are the days of climate change and high means flood and disasters. My topic of presentation is geospatial application in flood and landslide susceptibility mapping. Though I am from a background of forest resource management, so I might means I'm just in nutshell I'm just going to a brief overview of this, what is the so-called remote sensing. Any information acquired from object without physically in touch is known as this remote sensing. It's been US naval officer Evelyn Pruitt who coined this term, coined the term in remote sensing in back in 1950s. So this remote sensing is without physically in touch to the any area of interest or object of interest. It is been sensed uh, through different platforms like aerial platforms, terrestrial platforms, or uh, spatial platforms from it remotely from a far distance. So that so actually there are different types of remote sensing, like there are through passive remote sensing mainly, which use sun's energy illumination as the source of energy, and wherein there are another counterpart which is active remote sensing, which is nothing but which is nothing but one second. Yeah, which is active remote sensing, which is nothing but the source of illumination is means source of energy is the platform itself, the platform itself, and the backscattered information is being sensed by the sensor. Backscattered information is being sensed by the sensor, And for example, lidar, light detection and ranging, radar, radio detection and ranging, those are some of the active remote sensing platform means informations. And means in the case of passive remote sensing, n number of satellites since the invention of Landsat mission in 1970s, n number of space means missions has been successfully tested and used for the natural resource monitoring and management. So they are using basically the source of energy as sun, and there is a limitation. It cannot be used in night and all, and there are some limitations. But active remote sensing, we are producing the own source of energy and the backscattered information. In the active remote sensing, we have the reflected information. Okay, so and then it will go to the data acquisition part, and wherein we scientists, the GIS scientists will acquire it according to our use. The hydrologists will use their area of interest, their type of platform means sensors, and we usually in forestry and all, we used to get Landsat missions like OLI or thematic mapper, enhanced thematic mapper, or different missions, or spot, or linear image self scanner, different sensors. Nowadays Sentinel is also freely available nowadays. So all those things, and then the data processing comes. This is in nutshell, means without physically in touch to that area of interest or object of interest, we are acquiring the information, identifying, observing and measuring, the object of interest or the area of interest without being in touch. Okay, and this the how we are using the ultimate thing is the, as earlier used to say, no, everything is form of energy, and energy can neither be created nor be destroyed. This energy in it is for the sake of usage in remote sensing, the electromagnetic spectrum. In this electromagnetic spectrum, we have this gamma to radio waves according to the wavelength and frequencies, and the particular frequency which is visible to our human eye, which is being termed as visible. The humans are very brilliant, and those are visible to the human eye, which is from 400 to 700 nanometers, which has been taken as the visible band. And this band and near infrared, to some extent near infrared, those are the bands which is being used for this optical remote sensing. That's why you can see in the legend, the optical remote sensing used, the passive remote sensing, this visible and IR band is being used for this optical remote sensing. Where in this active remote sensing, you can see that this microwave remote sensing, or the active remote sensing is being used. So the gamma and X-rays and ultraviolet, those are the high energy bands. So we are it's not and it's harmful also, and it's not for this purpose. And this radio waves, we also all know, for communication purpose and all, communication satellite. So, and then this the beauty of this, according to the Lilsand et al., this is the beauty of this, the basics of this remote sensing, wherein we are using the spectral reflectance of each biophysical features according to the type and condition of each biophysical, means living and non-living biophysical features. We are the sensors which are deployed in different spatial platforms is sensing the information according to the spectral reflectance. Okay, because as I already told, energy can neither be created nor be destroyed. It can be transformed from one form to another. So this energy, the whatever is reflected back, is being sensed by the sensors in the case of passive remote sensing. And whatever is backscattered, the term is different. The backscattered with different polarization levels, vertical, horizontal, horizontal, vertical, like that, different accordingly, that is being sensed by that sensors deployed in different. So the sensors deployed tuned to get informations, as I mentioned, the Landsat missions or the Spot mission of France, or this Sentinel missions or European Space Agencies, different missions. No, they are tuned to get informations in different windows. They are getting informations according to their spatial. Then generally it is known as the characteristics of the sensors. The characteristics of the sensors means the spatial resolution, the resolving power of the sensor, different sensors, that can be spatially resolved by the sensor. Spatially resolved by the sensor. And that is the spatial resolution. And there are I mean to say that the radiometric resolutions, the radiometric energy levels, the quantum levels, the how much different it can be differentiated according to the energy levels, like radiometrically, that can be resolved by the sensor. That is its radiometric resolutions. It can be we used to say in bits, 2-bit data, 10 to the power of 2, 10 to the power of 2 to the power of 12, 2 to the power of 6, like that. So radiometric resolutions, and then spatial resolution, temporal resolutions, with how frequently it is revisiting the same area. That is the resolving power with respect to time. That is the temporal resolution. And spectral resolutions. Spectral resolution is the how the spectrally that can be resolved by that particular sensor. Thematic mapper is having one particular spectral resolution. Sentinel is having one particular spectral resolution. Means the spectral bands that can be resolved by the sensor. And nowadays hyperspectral sensors are there. Hundreds of bands are there in different hundreds of bands, 250 to 700. So how so many hyperspectral remote sensing is there, in which it is being differentiated based on the spectral bands. So spectrally, according to the spectral resolution, spatial resolution, how much spatially. For example, thematic mapper is having 30-meter resolutions for in general, 28.5 or something, but usually say 30 meter, 30 into 30 means 900 square meter. That is its spatial resolution. So in the case of the Sentinels and all, it is 10 into 10, 100 square meter. So that is the so different according to the spatial resolution, spectral resolution, temporal resolution, and radiometric resolution. It can acquire information in different. So that can be used by the geospatial scientists for different. For example, from this spectral reflectance, you can clearly see that the green one is, as I am from forestry background, it is for the vegetation curve, where you can see that I think, madam, is it visible? Hello? Hello?
Sir, yes, sir, it's visible.
Slides also visible?
Yes, slide is also visible, sir.
Okay, 1 second. Ma'am, now okay, no? Okay.
Okay, sir.
Okay, so this is the spectral reflectance curve as explained by the Landslide et al. So this is the basics of remote sensing, wherein different features. You can see that the blue one is for water, the green one is for vegetation, the dotted one is for soil. So different as I mentioned, type according to the type and condition of each biophysical features. Here the 3 physical features like soil is there, vegetation is there, water is there. So according to the type and condition, and why I mean to say that the condition. So the same forest, the same vegetation, the same water body, the same soil may not be changing that much, but still in the rainy condition it is changing. The reflectance will be changing because of the presence of the water. Okay, so in soil moisture index and all, we are working out on that property. So and water ratio indices. So different. So we are using this particular the basics of in any remote sensing. We are using this particular type according to the type and condition of each biophysical features. You are seeing this in the why this thing you are seeing the reflectance in percentage. So that much nearly 60% is 40% is reflected. That means 60% is absorbed, or the 60% of the energy is being transformed to either absorbed or another forms of energy, convection to heat, or some changes happen. So only 40 is reflected, means from this graph, or nearly 50% healthy vegetation and all. No, you can the reflectance is nearly 40 to 50. So that means that the exact mirror opposite is the absorption curves. The absorption curve is the entirely opposite. If you keep a mirror above it, it is the absorption curve. So the water body, it is having a particular high reflectance in blue band, and in the high reflectance in the blue band, and you can see that in this see between 0.5 to 0.7, as I told you, 400 nanometer to 700 nanometer is your visible band. So you can see that in this green portion there is a peak. There is a peak. So that is why we are seeing the vegetation as green. That is the sole reason. It doesn't mean that the vegetation is having highest reflectance in the green band. The vegetation is having highest reflectance in the electromagnetic spectrum. In the entire electromagnetic spectrum, it is having the highest reflectance in the near infrared band, NIR band. So this beautiful information will be used for the normal NDVIs, normalized difference vegetation index and all, wherein you are calculating the red edge effect. Yeah, the NIR minus red by NIR plus red. You are using that equation for figuring out the normalized difference vegetation index. So that is why, because to use this particular property of the vegetation. Likewise, the water body is having the hydrologists will be using that their particular. I told you, no, this water ratio index, also the soil moisture index, whether all these agriculture scientists and all. So different indices are there, which they are using this particular reflectance curve, or it is known as spectral signature. The beautiful term is the spectral signature, which means that each biophysical features according to the type and conditions means interacts with the incoming solar radiation differently, and whatever is reflected is being sensed by the sensor deployed far apart, either in aerial platforms or in the spatial platforms, or but different platforms. So in the sensors are getting the information whatever is reflected. I told you, in active remote sensing, the backscattered information, wherein the source of energy is the platform. From the platform itself, we are the source of information, source of the energy. Here, whatever is reflected. So according to the type and condition, for soil, you can see that the highest reflectance, you can see that in the mid infrared. See, in this mid infrared, the half after the half, no, the mid infrared portion from 1.8 to 2.5, that is the highest reflectance for the soil. So the soil scientists, they are interested in that particular wavelength band. They are using in the downloaded image, and they are getting information from that bands. So as forestries, we are interested in this band, particularly in the NIR, and as well as this there is a, you know why there is a depression in this 0.7. There is a depression in 0.7 as well as the 400 also, because in blue and red band photosynthesis happens. Photosynthesis happens means with the help of the photons from the sun, the entire vegetation is synthesizing the food. So in 400 nanometer, the photosystem 1 and the photosystem 2, 680 means 700 nanometer, the photosynthesis happen. That's why there is a depression in that spectral reflectance curve, wherein immediately after this red band, in the near infrared band, that is this peak, no, this peak is your NIR band. This peak, no, this is your NIR band. So this NIR minus red by NIR plus red, that is your NDVA. So we are using that particular indices. Soil science will be using another soil index according to their bands likewise. So the blue, green, red visible, and NIR band, they are used for passive, and this mid infrared for the soil scientists they are using. So water, you can see that the water, the surface category water, the low reflectance, they are having the low reflectance in the NIR band, but the high reflectance in the visible band. So they can use the indices accordingly. And the vegetation, low reflectance in the mid infrared and high in the NIR band. And soil, the soil is having low reflectance in the blue band, wherein it is having the high reflectance in the. So soil scientists will be using this particular feature of this spectral reflectance curve of that particular biophysical feature. Okay. So the vegetation, I didn't complete the why I told the condition. The same vegetation in the summer days, it will be leafless. For example, in most of the forest, no, in Kerala and all, it is moist deciduous and evergreen. So this moist deciduous forest means elapodium കാടുകൾ, means it will be leafless in summer. So at that time, the reflectance is different. You cannot get this pattern, because in leafless condition, the soil will come into picture, the rocks will be behind the tree. In summer condition, no, in dry conditions, the reflectance will be different. So that according to the different condition, type and condition of each biophysical feature, the interaction is different, and the whatever is reflected. So the forest itself, the same area, the same forest, it will according to in different seasons, it will interact, and reflectance will be different. So okay, I hope this much is clear, ma'am. Is it? Hello? 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 Is it audible, ma'am?
Yes, sir.
No, teacher. So far is clear, right?
Yeah.
Now I am going to the scenario of this disaster management. As you see, this among all disasters from the decade, the last century, you can see that of over a century, you can see that flood is dominating throughout the globe. Okay, then drought is also happening throughout the, but it is not as you can see that peak. It's nowadays after 80s or 90s or 2000, after the millennia, it is having a high peak. Okay, so all among the disasters, flood is dominating, and then comes this drought is also there, and earthquakes are there, but landslides. Why I am going to just give you an outline of this flood and landslides. Flood and landslides. In this, you can see that in both the cases, in this millennia, it is increasing. Okay, according to the Intergovernmental Panel on Climate Change. Okay, number of recorded natural disaster events from 900 to 1900 to 2023. This one. Okay, then you can see that nowadays, most 70% of the population is depending on the urban environment. See, for their living day-to-day activities, like for their sustenance, daily sustenance, for job opportunities. Okay, their it's a technology on their most of the cities throughout the globe, most of the nearly 60 to 70% of the population of the globe is in cities. So the rapid urbanization over these decades, the recent decades, okay, further intensify this climate change scenarios and all. So you can see that see, the world will be at 1+1.5 in the left side. You can see that this one. Annual hottest day temperature will be like this. Okay, annual mean total soil moisture, the soil moisture change, and the wettest day, you can see compare if there is an increase in 1.5 degrees Celsius, and what will be the world at +2 degrees Celsius. This you can see the hottest day and the soil moisture condition as well as the wettest. See, and if there is an increase in 3. In my study recently, I have a study in which over 2 decades, nearly 2 degrees Celsius, nearly this temperature is increased. So in these recent decades, because of this rapid the over exploitation of the natural resources for the different means high, see, and the carbon footprints are getting accumulated like anything. So when compared to the last century, this century, we are moving fast towards these adversities. Okay, so and you can see that what will happen if there is a world at +4 global warming, this +4 degrees Celsius, what will be the situations? Okay, according to the Intergovernmental Panel on Climate Change. And see, the climate change, the basics of this instability is this climate change. So increased temperatures and the precipitation, extreme precipitation, as we had the recently last very high dry days. No, recently in most of the Kerala part, you had dry, means all the wells were drained, and means there was scarcity for water and all. Now we have experiencing the extreme precipitations, more than what we are expecting. So the sea level rise, the coastal areas are more vulnerable to landslides and rising sea levels. Okay. So there are in the first I'm going to cover this flood, and this then I will go to just some basic methods, and then this the second case study of, and then I will go to this landslide will be also there. Okay, yeah, landslide part is there. Okay, so just I will go in. Okay. Okay, there are different types of floods, So there are types of flash floods, which is, this cloud burst, the in Himachal, the Himalayan tract, this Himachal Pradesh and Jammu Kashmir, and those parts, Uttaranchal, all those parts, where the Himalayas, the common in the mountain regions. You have seen that Kashi means recently we had in this the last year and this year also. So this common in mountain regions wherein slopes are steep and subject to frequency and the fluvial or riverine floods. It is due to as a result of, we have seen that in Brahmaputra, Ganges, and all, exceeding the capacity of the stream channels, and it's overspilling the natural banks. The fluvial or riverine floods are there. So that is another type of floods, and the seasonal floods, according to the seasons, like occurrent general irregularity as a result of major seasonal. That's again Ganges, Brahmaputra, all those comes in that also. That can be categorized in that also. Pluvial as well as seasonal floods, and then coastal floods, tsunami. We have in last decades we have seen the tsunami in the southern India, the storm surges, the estuarine floods in the estuaries, where in the it meets the sea, that deltaic areas of rivers, due to the interaction between the fresh water in the river saline from the water from the sea during the high tides and all, estuarine floods, and then the man-made one, the urban floods, caused by the extreme rainfall, but because of this climate change issues, global warming, and with the inadequate drainage system. That is the main thing. Inadequate drainage system. We have over the decades we have most of the wetlands in Delhi high big cities, metropolitan cities. 50 to 70% of these wetlands they have converted into the land mafias has been converted because of the land price. No, they are created high skyscrapers, and nowadays the flood, because earlier there were this wetlands, this core lands, this whatever with the they have the acting like a sponge, and nowadays they have all been converted into this built up areas, and means without. See, nowadays we are not seeing at a grass at all in front of our home. Everyone is tiling, and the roof, everything, everything is increasing the temperature. That's global, contributing to the global warming, and the drainage is not there. So that's why this urban floods, due to excessive snow melt, that is snow melt floods, then ice debris dam floods. Okay, so the impact of climate change, you can in the right side you can see that it is up to 2023 only. You can see that the Odisha super cyclone, different extreme climate events. What happened? Flood in JNK 2014, cyclone, and flood in Tamil Nadu 2015. Okay, that much amount of money means the infrastructure has been lost, and this extremes you can see that in 18 in Kerala and all we have witnessed in 18 the century flood of the century, flood of the century we have witnessed. You can see that the light see this you can differentiate these two graphs, these two lines, you see. So that in August you can see that in the July and August how much this difference happened in 2019. Okay, so these are the impact this impact of by virtue of this climate change and all these things, and by virtue of these heat islands. Nowadays I'm already winded up one project, and it's going to submit to the funding agency. This in different municipal corporations, of Kerala, how this heat island effect or UHI, all this the flooding also I am doing now. So these are large urban agglomerations that function as these heat islands, and further raising the air temperature in the localized areas. There are microclimate and macroclimate, or a small area microclimate. So this resulting microclimate may further increase the amount of intensity of the precipitation in that urban areas. See, the climate change is likely to increase the magnitude and frequency of this extreme storm events. Okay. So you can see some of the pictures, the Beijing, China, what happened everywhere. Globally, it is the same. The impact is same in China nowadays, in this year itself, in Pakistan. Okay. So the New York, how it happened, the Bangladesh, what happened. See the Chennai airport. See, you can see the Mumbai, what happened in 2017, Bangalore. So the spawn city concept, we are going towards nature. We are going towards nature. See, Kochi aims to evolve what spawn cities like this. I told you the wetlands, the cold wetlands. What they are doing they will be acting like a sponge to see wherever this to get rid of this inundation or floods. They will be so nowadays we are going to means this concept means more towards nature. The wherever the afforestation programs, the trees, wherever there is a space for trees and vertical means so many. I will show you the picture. Okay, so cities that are flooded on, you can see that the spawn city in urban areas uses natural areas to absorb rain. I will show the pictures. Okay, then it will be more clear to you. So Kochi aims to evolve into spawn city to avoid flooding. Okay, we are also in that list, spawn city. And impact of urbanization, you can see that from this graph, this how this urbanization happened influences adversely. And this land use land cover means the how much the land use, what are the land use in that particular, for example, land built up area, vegetation, or the roads, or the agricultural land, plantations, different this thing. No, so you can see from this graph, see the higher peak. See this, you can see this dotted line. It is post development. After some developmental activities in a particular area, what happens? You can see from this graph. And what was the condition pre-development? You can just easily get the clear picture. The flow rate on the y-axis it is flow rate, and the right x-axis it is time. With respect to time, how it is, how the flow rate. See, as the after the development, the unscientifically over exploited natural resources, where the wetlands being converted into this lands, and means wherever the inch is there, the built up, and this impervious materials, wherever in the grounds there are impervious tiles are there, so there is no scope for drainage. You see, and means earlier in Trivandrum, I'm from my parents, I used to hear that in Trivandrum and all. But at that time, that population and that much over exploitation of the resources was not there. That is true, I admit. But the drainage system was up to that according to the carrying capacity. Now the carrying capacity exceeded. See, the population over exploitation, over population, the wherever the demand of the area, that means wherever there is built up areas are coming up, the roads are coming up, the flyovers are coming up, everywhere development. That is, it is needed, but it should be done in through environmental impact assessment, all those things. No, we have to do that. Otherwise, this kind of it is not only we Kerala or India are not an exclusion. Everywhere it is the same, in China, everywhere. Because of over exploitation of the natural resources, unscientifically converting one particular land use, or the so-called the sponges into built-up areas or roads or of the constructions, this will happen. So you can see that the higher peaks, the flow will be very high. Within no time, you see. And why we are talking about urban floods? Because the human are in forest also it's happening, but the intensity is less, and poor animals are suffering, the wild animals. So we are least bothered. But in when it happens to these urban and rural areas, we are bothered. So we always nowadays say that this the casualties, because the casualties will be more, no, in the urban cities. So in rural areas, the casualties will be less, or the mortalities will be less. So this is having high. Urban floods are getting more emphasis nowadays. So higher peak you can see, wherein before conversion you can see the blue line, which is lower peaks, you see. So, and you can see from the diagrams, you can clearly see what happens in natural ground cover. Only 10% runoff, 20 infiltration is high, shallow infiltration, because the trees will increase the infiltration rate. Water holding capacity will be, physical properties of the soil will be balanced when the trees are there, through root systems, through the soil, means the associated micro and macro organisms. So this shallow infiltration, and then deep infiltration through happens also, and then 40% evapotranspiration. Okay, because evapotranspiration loss because of this vegetation, that is 40%. You can see in the next one, the building came 25 become 21 shallow to 21, and because of the 10 to 20% impervious surface, what happened, the vegetation less, and the 30, then because of that this 38% it reduced, and the filtration, deep infiltration became 21%. Okay, runoff became increased to from 10 to 20%. Okay, you can see in the next picture where the 35 to 50% impervious surface. Okay, because in like in our Thrissur city and all, where means kind of mid city, means it's not that kind of metro city, means big cities, no. So that kind of cities, you can see that increase, the runoff is increased 30% because of this impervious layers, 35 to 50% impervious surface. And because the vegetation is less, still the vegetation is there, because then 35% evapotranspiration, and infiltration reduced to 15% because there is no vegetation, and or the the contribution from the mother nature. And in the other case, you can see this in higher cities and all, you can see that 75 to 100% impervious surface, the roads, the constructions, the flyovers or whatever. So the infiltration is very less, the evapotranspiration is also less, getting less, and then you can see this runoff. So that is the sole reason of this urban floods. What is in nutshell, this is the in nutshell what is happening through the contribution from the Homo sapiens, impact of urbanization and land use cover, according to Razay et al. 2019. Okay, increase in flood peak by the order of 8 times, and the flood surcharge by 6 times, according to the Razay et al. Okay, though, and then now I'm going to this geospatial technology. The most commonly used one is this analytical hierarchical process, wherein as the name indicates, see, it's a very good scientific. It's developed by Sati et al. And this one is being used for not only geospatial science, different sciences, social sciences, biosciences, different sciences. It's been used to figure out the priority, to make the ranking, which factor we should give more ranking. So this an HP method, nowadays online HP calculators are there, wherein you can do that, this criteria weighting. See, for example, in flood and all, where the low elevation areas prone to flood, near to a river prone to flood. Okay, the slope, the rainfall, these are the factors. Some, for example, these are some of the factors which are contributing to the flood. Okay, so general factors. Okay, and our own contribution, our own contributions, drainage density, all those things, topographical wetness index, and all those things. So this factor ranking, each factor is ranked based on its contribution to the flood susceptibility, and that we are figuring out through HP. We are consulting this one-to-one survey or focal group discussion with the scientific experts. For example, the landslides, the Disaster Management Authority, KSDMA, National Disaster Management Authority, or the pioneers, the scientists who are working in this field, whoever is working in this field, we are consulting them. We are prioritizing, see, according to our study area, what was the main factors to be given more weightage accordingly. That is another thing. And then through our field experience, our own experience, our literature review, what in this particular area, what all are the factors. For example, the Churalmala in Wayanad, what happened, and what happened in Idiki. So different areas. What are the for example, so Churalmala is the landslide. Sorry, so Idiki was landslide came in. So different factors are coming in both the case of landslide as well as flood. In landslide, what happens? The elevation matters. Elevation and slope matters. The more the high risk, no, and the nearness to roads. If the road and the urban area, the human settlements are nearby, the more casualties or more this thing, more mortalities will come. So accordingly, we are waiting different elevation or rainfall or the slope, all those things we are waiting. So each factor is ranked, and the susceptibility mapping. Finally, a spatial model combines according to this weighted overlay analysis through ArcGIS or QGIS, different spatial platforms. You can do it. We can do it. The susceptibility mapping. Then another method is another method. Then frequency ratio. How frequently this particular happens in one particular example, Cochin, in Mumbai or Chennai. The flood occurrence data are analyzed and determine the frequency of floods within the land cover categories. That is another method. Frequency ratios are calculated indicating the probability of flooding. And then frequency ratios are applied to land cover map to create the flood susceptibility map. That is another ratio. That is frequency ratio. Then HP method. Then another one is the machine learning. Nowadays, everyone in artificial intelligence, artificial intelligence. So machine learning approaches. There are deep neural networks, artificial neural networks. So support vector machine, random forest, XGBoost. So different machine learning algorithms are there. Okay, so wherein you are using the beauty of this machine learning approach, that there is no scarcity for the data sets. And the data, you a huge number of data, cloud data. We have so many means whatever we want nowadays in your fingertip through this AI method, AI means machine learning approaches. And we can, if the only thing, if we have to be bit more shrewd in your programming and all those things. And nowadays that also is through free through artificial intelligence. Through logistic regression, statistical model predicts the flood susceptibility based on a set of input factors. Okay, like there also the factors are same. We are analyzing from the literature, from the different science. We are analyzing what are the factors contributing to that particular area. Then the parameters we are, then the decision tree based model identify the rules and patterns in the data to classify the areas into flood prone or the less prone areas. And the artificial neural networks, the complex model learns from the patterns in the data to predict the flood susceptibility. That is also good. And then support vector machines, I told you, a powerful model that separates the flood prone areas from the non flood prone areas based on the data, hyperpine the data. Okay, so these are the different approaches. HPL third, and the frequency ratio and the machine learning approaches. And there are different, as for in everything, there are pros and cons. And the AHP method, the considered subjective expert opinion, as I mentioned, and easy to implement. And the other case, it is can introduce bias limited to small number of factors. No, so in the other side. So in the case of frequency ratio, relatively simple, relies on the historical flood data. Yes, even you can do through Excel. This, and then SPSS, anything. So this SPSS or time series analysis, you can do that. Okay, time series, what is the SARIMAX, seasonal impact of climate change and all, no, seasonal auto aggressive integrated moving average, SARIMA moving average method, SARIMA seasonal, yeah, auto-regressive, SARIMAX models. Okay, the different time series model require extensive flood data, sensitive to data quality. And then machine learning models handle patterns, potential, and the complex data, handles complex data patterns, and but high accuracy, because by virtue of its handling power of the complex data patterns, it is having the high accuracy potential, and that requires high significant computational resources. Because you are handling with GBs of data, so you require high significant computational resources may offer with the training data sets, wherein you need the training as well as the validation data sets. Okay. And the first case study, for example, to delineate the flood susceptible zones of Kozhikode district, it is a superficial study itself. It's not a deep study. It's just to for the training purpose, and wherein we have used the spatial data sets like SRTM DEM, shuttle radar topographic mission, digital elevation model. From that, you can see that SRTM DEM. From that SRTM DEM, you can get the slope, elevation, distance from river, drainage density, and topographic wetness. The more the parameters you can use, the more the precise. See, this is flood, no? WRI, water source, water ratio index also you can take. Okay. And so the more the parameters you, as per the literatures, so the surveys, the more parameters you can use for this training purpose. In my training and all, I used to give only for this kind of from the data set, and from Giovanni and Indian meteorological data. You can get IMD data sets as well as Giovanni data sets, the rainfall data, and from Sentinel-2 land use land cover. And through HP calculation, I told you through HP calculator and all, this weighted, we are figuring out which factor to give more importance, whether to give more importance to slope from this methodology flowchart, whether to give more importance to elevation. For example, out of 100%, 20% to slope, as sorry, this is elevation, no, plus flood elevation, 15% to slope, or distance from river 20%, because the more near to river, the more the chance of flood. So drainage density, so accordingly we are giving weightage. The rainfall also giving 10 to 15% among the 100%. Land use land cover also having influence, because I told you, if I am doing it in urban area, land use land cover also having built up area. The built up areas contributes more towards this flood, because the unscientific overexploitation of this built up areas in the natural areas of this, otherwise where this happened. So this, and then we will do this. So different, so I told you, no, in urban area, LULC may be having more weightage. In normal areas like other areas, you have different way. So according to the your from the experts, from the scientific experts, through disaster management, I told you, different stakeholders, the forest department, different local development, local LSG, local self-government group, so different stakeholders, local self-government department, LSGD. So different stakeholders are there. We are getting information from them, and from the very important, the depending the whoever staying there, those community. So we are getting information. So then ultimately, if you are taking pain in this, collecting all this information, you will have a very good flood susceptibility map through this. Okay, for example, in this was the region for Kozhikode district. In Kozhikode district, for different slope map. Okay, distance from river map in the first one on the left side. That was we have given some buffer, and the reclassified slope map, and the reclassified drainage density map, reclassified topographical wetness index map, TWI. TWI also can be availed from this SRTM. Okay, and then TWI map, and then reclassified rainfall map, and then land use land cover map with this 1, 2, 3, 4, 5, 6. I told you, the more the layers, the more will be its precision. Okay, and reclassified elevation map. This is the reclassified elevation map. Sorry, 1, 2, 3, 4, 7 layers reclassified elevation maps, and you are giving this through this analytical hierarchical process through AHP calculators. You are giving who all are the factors giving more equal importance. For example, whether slope and elevation is having equal importance, or slope or different like that. Moderate importance, okay. The equal importance will be the intensity is 1, and the moderate importance 3, strong importance, experience and judgment strongly favor one element. For example, in my experience, I will give elevation more than slope, because the low elevation areas are more susceptible to flood. In the case of flood only. In the case of landslide, higher the elevation, more susceptible to flood. Vice versa, because that is sleep areas, no. So just for example, I will give more in the landslide, I will give more in the high elevation areas, but in this case, low elevation area is having more in general knowledge. No, low elevated area will be flooding, high elevated area will be safe from flooding. So like that. So accordingly, ranking will be given, and the weightage through this. That weightage, intensity, and all those things you are giving in the HP calculator. After a process, it's a long process. I told you, through FGD one-to-one survey, and from the scientific experts, and all those, the literature survey, whoever is very good peer-reviewed journals, very good studies are there. You are analyzing that also, and from your experience, okay, local experience, everything, and then you are ultimately this assigning the ranks for the thematic layers, because we have 7 layers here. We have to give ranking, and you are giving more weightage. See here, as per in this study, we have used more weightage to topographical wetness index than elevation. Sorry, then given to distance from river 20. Sorry. First given drainage density 22%, then given topographical wetness index 21%, distance to river 20%. So 60% is over. More than 60% is over. The rest is elevation given 12%, and then rainfall given 15%. Land use, land cover, as it is a general മൊത്തത്തിലുള്ള area ആയതുകൊണ്ട് കോഴിക്കോട് district, it is other non built up areas are also more. It is given this 3%. So then this is the ultimate result, the flood susceptibility map. And from my friends from the flood, the Kozhikode district, I came to know this was approx, because I have not used that much parameters. No, approximately this is correct. Wherever the light blues are there, very low occurrence. Okay, wherever this you can see that line. No, those are the rivers. The nearby those areas, it's moderate and high and very high risk zones. Okay, the area of the flood susceptibility map has been grouped into 5 classes, like the very very low susceptibility, the towards the from the coastal to upper area. Okay, towards towards the western side. Okay, western side of that Kozhikode district. Okay, so then namely very low, moderate, high, and very high. And most of the very high susceptible areas is in the western side, that is near the towards the eastern side and Korva. Western side, number Arabicadal means towards the Arabian Sea, it is very high. Towards the Arabian Sea, the western side, it is very high. And you know that there is a very western Ghats are also there in between. You all might be aware of western Ghats, and which are the sole reason Kerala and the Karnataka and means Goa and Maharashtra, those parts, we are getting more rainfall in the usual monsoon, northwest monsoon. We are getting more rainfall because of this western Ghats mainly. Okay, so we have more means chances of this flood also in this region because of this rainfall. Rainfall is very high, no, in north, in especially in this August, all those time, no, we have seen that graph, no, July, August, those graphs, you can see that. See, August, it is very high in 2019. That's why we had flood. Okay, so so that kind of the western side, I wrongly said that towards the towards the Tamil Nadu, or the towards eastern side. Okay, there is less. Okay, so towards western side it is more. So most very high susceptible areas in the western Ghats, that is near the coastal region. And from my friends from this Kozhikode region, they said the same. It is almost correct, or approximately correct. Okay, if I use more data sets, more parameters, it will be more clear. And if I have taken at least 1 year for my study, then it will be more clear. And I can use the same data sets for this machine learning approaches, and the frequency ratios different. You can compare how different methods are getting information for the same area. Okay, then that is also another method. Then the validation from the Kerala State Disaster Management Authority, it was very good. Means validation was used from this Kerala flood data from 2018 and all. It was more or less accurate. And another method is through the same method. Like, for example, I gave one case study to one of my experiential learning student, Asif Shah, who was a native of Alapura also. So he knows this Alapura region and all. Then he did the same methodology. The same methodology. He did it for wherein the DEM data used this kind of slope, elevation, distance from river, all those things. Giovanni rainfall data, Sentinel. So the same methodology they used, and the same kind of different according to the Alapura district. The same for drainage density map, as well as the map of slope map, as well as the map or reclassified topographical wetness index map, reclassified rainfall map, reclassified land use land cover map, elevation map, as well as the distance from river. So different maps. We have different means different layers we created, and this on the left side you can see that through HP calculator how you are doing this ranking and all those things, and according to the decision matrix, the finally the weightage of the factors for that Alapura region. You can see that in Kozhikodu you could see that elevation got 12% weightage, but in Alapura Alapura got 31%. Why? Because you all might be knowing throughout the year it's a low elevation area. No, it is a low elevated area. So low elevation area always under floods. So Kuttanad, all those things. So always under flood means the small the rise will be small rise in sea rise will result in floods. So elevation is contributing more. So according to your locality, according to your different regions, in Kozhikodu it is different. In Kozhikodu your weightage will be different. You are giving different weightage for drainage density, land use land cover, and all distance, all those things. But here in Alapi, it is given more weightage to elevation. Slope is given another 25%. So distance from, so accordingly, according to your region, these weightage. That's why I told you from experts, from review and all those things. Your experience, your one-to-one survey, GD, all those things. You will get through HP method. You will weightage. Once this weightage of factors is correct, no. Once this weightage, once you are giving is correct, then the map is perfect. Okay. So this is the as per him, that student. He told that it was exactly correct, sir. In his home area, this was the condition, the flooded region in that 2019 time. Both the northern and the southern region are showing high risk according to this map. Okay, and the western side also. Validation were done through the flood prone maps. Okay, NCES data and all we used. The same. You can see that the blue. You can see that. See, we haven't used that much parameters. You can clearly see in most of the 70% is correct. 70% of the, and he has made this presentation and he got in the Congress, and he got very good result also. Okay, now I am going to this law impact design. I told you the spawn city concept and all. We are going, there is no other go. We should go more towards nature. I admit there is a huge demand for the development that is there. That without development we cannot sustain. That is also there. But we have to use the natural resources scientifically. Then there is a scope for the future generations. Otherwise, as we have seen in Kalki film and all, that will be our end. Okay. So law impact designs refers to the approach to the land development that works with the nature to manage stormwater as close to source as possible. See, where evideano prashna means wherever the source, there you are making the sink, so that it will not go as runoff. I have shown you in that picture. Runoff will be more through this the more the impervious layers, the more will be the runoff. The less will be the infiltration. The less will be the infiltration. In the earlier graph, no, earlier one of the slide I shown you, you can see in this, the more the impervious surface, less will be the evapotranspiration, more will be the runoff, and less will be the deep infiltration, less will be the shallow infiltration. The infiltration as a whole is less. So we are making in low impact designs and all nowadays, low impact designs, we are making the source, in the source itself we are making the stormwater as close to the source as possible, the sink, through infiltration. Okay, so that the inundation will not happen. Filtering, storing, evaporating. And nowadays the concepts are coming even purifying. Okay, So evaporating, and to reduce the quantity and improve the quality of the stormwater runoff, it was first proposed by the North America. LID benefits: reduce impervious surfaces because we are more giving more towards nature, managing the runoff rate and duration, improves the water quality, mimicking the nature, and reduces the pollution as per the Chinese Li et al. 2020. Okay, he is one of my professor. We have recently found, we have seen in international conference in Durban, international conference on environmental and earth sciences 2025. It was hosted by this guy in Durban. Okay, and another Indian counterpart, Vetrimel. So we have seen this guy, and according to his study, this LID, this is the benefits. So that this is the detention pond. So he's a scientist in earth and environmental science. That's why he did wonderful job in this. Okay, so detention pond, porous pavements, and swales. You know, the shallow. You can see the convex as well as this. You can put mud. You can make a convex slope. Convex also, that is known as berm. BERM berm. And when it is convex, like this gray swales, no, you see this one. This is concave, so that the water can be, and the gray grass is used instead of concrete and all. Grass swales, and porous pavements. You are not this. The pavements are there, but you are it is making as porous. You are not concreting in between, so that the water will be getting drainage. That, or the another thing is simply put this now, the metal. It will be good for your barefoot, as well as it is the water, the drainage will be more, infiltration will be more, runoff will be less. Okay, so detention ponds. See, these are the types of ponds I told you. Know the 70% of these areas in metro cities, high metro cities nowadays, they are beyond metros, cosmopolitan cities nowadays. The Mumbai and Delhi and all, no, they are cosmopolitan. They are no more metropolitans. According to the population, the infrastructure, and all, they're 70 to 75%. Most of these kind of ponds or detention pond, water holding sponges, detention ponds, been converted by the land mafias to unscientific. Because why it is unscientific? Because it was like that only by the nature. So you have another scape. You can use the another spaces, no. But those areas near to this big city hotspots, no, they're unscientifically. You see, the more you cannot place, the more you near to cannot place, the demand for the land will be more. The more will be near to the central building, means central administration, parliaments, and all those areas, India Gate, all those things, all those areas will be huge demand. So I'm telling an example. So they're converting the land, the ponds or those wetlands to like anything, and this created this kind of issues nowadays in Chennai. Unscientifically, they have converted. Then infiltration trench. See, infiltration. You can see that the infiltration trenches are made with herbs and shrubs, boulders, and then rain gardens. You can see rain gardens. Then nowadays, these vertical gardens, the green roofs. Nowadays, you can see that in Bangalore and all, and in Mumbai, all those buildings are with vegetations. You can see that is known as the green roofs. There is no other go. We have to make it green roofs because of this huge demand of this cosmopolitan cities. We are in those areas. There are, in wherever the area is there, you can make this rain gardens, infiltration trench, and all those things. And you can see that as per that different studies, you can see that detention pond creation in China. You can see that 92% of reduction in the peak flow rate. I have shown you one graph. That peak flow rate, you have shown, I have shown you this peak flow rate. You can see this. You can see this peak flow. See this peak flow. It has been namely 92% is reduced. You see, and different studies. Palermo, Italy; Sang et al., Beijing, China. Okay, retention tank. What they have done? Low-impact design, retention tank, grass wales, and green roof in Beijing, the capital of China. reduction of runoff volume by 50%, and flow rate, peak flow rate by 70%. You see, that much difference is happened. You should go to the nature. We should go, not we, you, we all, including ourselves, everyone. Everyone should go to this towards nature. There is no other go. Okay. Okay. Then yeah, Ahmad et al. In Malaysia. Okay, Havlik and Treadway in USA. Different studies. So the long back design is very good for reduction of the peak flow. So the urban floods will be less. Ultimately, nowadays everyone is making what to say. രാഷ്ട്രീയക്കാർ അങ്ങോട്ടും ഇങ്ങോട്ട് പറഞ്ഞതിന് നല്ലത് ഇങ്ങനത്തെ you have to go towards this low impact designs. Okay, so the Kerala floods, you can see that in different fatality count and excess monsoon rate. What happened, you can see in this table in 1 to 19 August 2018. What happened, the normal rainfall expected was this much, and the actual rainfall happened was this 758. Okay, in July, what the expected one was this, and so overall from the normal rainfall there was a big deviation was there. That is the one of the sole reason was happened in according to the Kerala State Disaster Management Authority. So, and the flood and landslide, in the left side it is the flood data in the as per that flooded region in 2018-19. You can see that those were wherever this white they have saved, the other one all suffered. You see, and you can see as I already mentioned. Now our next interested one is the landslide, right? Landslide, you can see in the Western Ghat region, in the Idiki, the high elevation region, in all these towards in this Western Ghat part of the Kerala, high elevated Western Ghat part of Kerala. Okay, what is happening, you see, because of the slope and elevation, and the incidence is more in Idiki and all. You see here, Pathanamthitta, Idiki and all, because of this. See, Munnar Kayetam, we all heard, no? Encroachment, what happened in Munnar and all. So wherever it will happen, but wherever we are encroaching that area for our own selfish means whatever be the so-called purpose, and we are creating resorts and all those things, and in the slopes without any proper care, the casualties and mortalities will be more as per if you are creating but there is no, you can see that in Trivandrum, Kollam, and Kollam is only few incidents. You see, in Thrissur it is also in moderate. Okay, Palakkad less. So wherever this high Wayanad, you can see in Wayanad you can see, because it is high elevation. Churalmala, you can see now, you can see here. Okay, so here also AHP heuristic method, the same methodology we are using. So I will not use much time, as I did explained in the case of flood. The same method we are using for this also. The analytical hierarchical method, analytical HP method we have used. Yeah, analytical. I am late, ma'am. Anu, madam. Hello.
Yes, sir.
Am I late?
No, sir. You can take.
So okay. So in landslide also, that we are for any disaster management, any disaster, you can use this particular beautiful technology like the geospatial technology. Okay, in one of the method is the AHP method. Factors are prioritized and the weights are assigned and the scores are calculated according to the, see for example, each location yielding a susceptibility map and statistical method, logistic regression applications. Landslide occurrence are modeled. It's a function of influencing factors, and model coefficients quantify the impact of each factor, and then probabilities, frequency ratios. That is the frequency ratio, that is the statistical one, and the machine learning method, the random forest implementation. Because most of the cases the random forests give more edge on the other supporting vector machine, XGBoost or other machine learning algorithms. So the model learns from the data patterns, as I already said, and the multiple decision trees are combined to improve the accuracy and robustness. The predictions are made for each location, generating a susceptibility map. And for example, the case studies for Nilambur, one of my friend did this work, landslide risk zonation mapping of Nilambur. Irshad has done this work, and as per his study, the study aims to assess the geospatial technology based landslide risk of the Nilambur Taluk, Malappuram district, and the objective was to create a reclassify thematic layers of casualty parameters to calculate the weightage of each causality parameters using ranking, rating, and HP methods, and to generate the landslide vulnerable zones. And these are the methodology flowchart for that. And we have the use different spatial data sets, allows pulsar DEM, and then allows pulsar instead of SRTM. He used allows pulsar DEM, which is having 12.5 spatial resolution. I remind you, I told you in the earlier part of this session, spatial resolution. 12.5 into 12.5 is the spatial resolution of this allows pulsar DEM. So you can use according to your use, you can use the select your sensor. Okay, SRTM DEM is having less spatial resolution. Then Giovanni, then the sentinel data 10 meter means 10 meter is the spatial resolution. Landsat TM, that 28.5 meter means Landsat TM, that 28.5 is the spatial resolution of that sensor. So according to your use, for our forest management, our large area, no, we have forest area, we have 1/3 of the geographical region is vegetation cover. We just want to cover the difference in forest types and all. In that case, I can use the Landsat TM or the Landsat OLI map, because spatial, I don't need much this thing. But in urban areas and all, I need spatial resolution more, because my recommendations and policy recommendations should be having the area, the areas, the change is different. No, nearby there will be trees, nearby there will be parks, nearby there will be built up areas, nearby there will be roads. So the spatial resolution should be more. So in Google Earth and all the Kickbird iconos, they are giving very good resolution nowadays. That's why we are using it through the global navigation system, GPS and all. We are using through that, and now India also have. India recently we have Indian regional navigation satellite system also, IRNSS. But we are tuned to get navigation the purpose of Indian region only. The polycon, we are mostly using the Mount Everest polyconic projections. So because of this Everest, we have undulating terrain, no, through from the Himalayas to Alapi, low elevated areas. So we are using those kind of projections for this navigation satellite. But it is limited to Indian region only. Indian regional navigation satellite systems. Likewise, China is having. Likewise, European Space Agency is having. Galileo, Russia is having. Sorry, GLONASS. GLONASS is Russia. GLONASS is Russia, and so different navigation satellite is there. We are in nutshell, we are using accordingly. Okay, so the non-spatial data here in the case of landslide. Why in landslides? These through hills in Munnar and all, you have seen this through Idiki everywhere. You can see that through hills you have roads. So that transport network we have, you have to get. That is another data sets we have, distance to get the distance from roads. So other than that, we will get all this through slope, elevation, distance from river, rainfall, land use, land cover, everything lineaments through DEM, and then Giovanni rainfall data, soil texture data from ISRIC grid, the ISRIC FAO data sets. You will get the soil texture data, and then the ranking method, the rating method. He has done different method, rating method and IHP method, and he figure out the landslide zone. So this is the class he has given for this. I told you, the more rainfall, the scale, accordingly the scale is different. This will ultimately you are giving in the HP calculator. In the land use land cover, the trees background, what will be the scale, built up area, what will be the C. In land use land cover with the built up area, it is 5. Why? Landslide, the built up area, if it is there, it will be high risk, no? So slope, 45%, more than 45% slope, 5. Why? Because it is high risk. Elevation, no, elevation, the slope is more, elevation more than 2005. Why? Because the more the elevation, more landslide chance. Okay, slope, elevation, all those things. The transportation network, if the network is more, the transportation network 0 to 500 plus 0, the more the nearness to these locations, it will be high rated. Okay. And then the lineaments and the soil and the distance from river, all those things, factors he has studied, and accordingly has figured out this slope map, as well as the rainfall. Why we did IDW means, in most of the Giovanni and all those things, we will get, because it's a small area, no, he got only 1 point, so we have done IDW method so that it will cover the whole area. And then we have taken that, and then the land use land cover of that particular area from the Sentinel. And then this digital elevation model, elevation we have taken, and the transportation network of the Smalpuram district, and the landslide lineaments is very important for this landslide, so lineaments also. And then soil texture also taken. Soil is also contributing to the landslide. The type and the parent material also. The more the the more the parameters you are taking, it will be more. The more precise will be your output. The soil texture and the distance from river also, that we done. And then finally this multi-criteria decision analysis through HP and all, and multi-criteria decision analysis, and the actual weightage were given according to the ranking. And then he has done two methods, ranking and rating method. And ultimately you can see that in the actual weightage he has given for elevation 10, land use land cover 17, has given slopes 35% according to his study and his experience, rainfall also. So according to his studies, this was the weightage given, and the weighted overlay analysis was done. And different methods he is comparing for ranking method, rating method, and HP method. And let me tell you, HP method was better. So from this method, HP method is the most suitable for the landslide risk zone mapping in the study area. And then another one, landslide susceptibility of Idiki district. Idiki district, you can see that the same methodology we are adopting, and HP and weighted overlay analysis, and the landslide susceptibility map. So these are the different maps. As per that, we have taken for the training data as the slope and the rainfall and the landslide, land use land cover, and the distance from rivers, and distance from flood, distance from roads, and the elevation map of Idiki. Elevation map, you can see that, you see how much how elevated in these regions, you see, and yellow and dark brown, all those things. No, it is these regions are very high prone. Okay, even
Hello, sir. Hello. Sir, are you there? Hello. Sir, are you there?
hello.
Sir, can you hear me?
Hello.
Sir, we can hear you.
ഹലോ കറണ്ട് പോയി മാഡം. ഹലോ.
Sir, ഇപ്പൊ കേൾക്കുന്നുണ്ട്.
ഇതിപ്പോ ഞാൻ എന്റെ ഫ്രണ്ടിന്റെ ഒരു ഹോട്ട്സ്പോട്ടിലാണ്. അപ്പൊ ഞാൻ എവിടെയാ പറഞ്ഞിട്ട്? Okay, so this were the, so far it was clear, no?
Okay, sir.
Hello.
Okay, sir.
So far it was audible, no? Or this slide you heard this slide?
Yes, sir.
Okay, so you can see that in Idiki, this region you can see that this high elevated regions, and in the KSDMA map also it was high risk prone area. So these are the different layers. And finally, the landslide susceptibility map of Idiki, we could see that the very high risk zones are 26.5% is the very high risk zone. Okay, so though this method. This we have not used the scientific, what to say, the literature review or the proper methods. So that's why this map is not that good, because that the HP we did was not that good. The data information we have collected through the literature review. This is just for, I have shown for this training, that training purpose. So this is the, those wherever this red dark red is there, that is the highest risk zones. Okay, risk zones. And when we validated, no, when we validated, you can see that landslide inventory map of Idiki. You can see these dot spots. Okay, and you can see this our study also, the landslide map we have created. No, you can see that those, this nearby only. It is, I told you, the more the parameters and the better the your IHP method, the better will be your output. So we couldn't do justify that to this study, but we still, through our HP method and through the beautiness of this geospatial technology, we could make uh, you can see that major landslide location, it is almost clear, almost same, which is being given by this KSDMA or National Disaster Management Authority from this inventory data. And you can see on this inside, Upputodu, Adimali, you can see, you might have heard in the papers and all, Munnar hill station, all those things. Now Munnar, you can see that all these areas, okay, all this area, Pyramid. Okay, I am sure that 100% sure that these places you had in the last decade, you have seen these areas were prone to landslides. Okay, so we could do justice in that aspect, but we couldn't do justice to that HP proper HP we didn't done. Okay, so this was the another Chalakudi River Basin flood susceptibility map. I just recently in Kerala Science Congress, no, recently Kerala Science Congress in the last year, it was happened in our campus, Kerala Agriculture University campus. The whole Kerala Science Congress happened. It was done, organized by this KFRI. So wherein I presented this paper also. My one of my student Murali, my PhD student, he did this. And yeah, one more. There are some. One minute. These kind of methods like uh, mesh bending, terrace farming, see, mesh binding, all those things, no, and proper concreting, all those things. It will to some extent. It is clear, no, right? Hello, and teacher, അത് clear അല്ലേ? These kind of
ഓപ്പണായി വരുന്നേ
this
ഉള്ളൂ.
kind. ഏതാ
ഓപ്പണായി വരുന്നേ ഉള്ളൂ.
തോന്നില്ലേ?
ഒരു PPT ഓപ്പൺ ആവുന്നുണ്ട്.
വൈഫൈ മാറ്റണോ? അല്ല, അത് കുഴപ്പമില്ലല്ലോ, കണക്റ്റഡ് അല്ലേ? ഇപ്പൊ കിട്ടിയോ? കണ്ടോ?
ആ സർ,
ഈ മെഷ് ബൈൻഡിങ് ഒക്കെ ഉണ്ടോ?
ക്ലിയർ ആണ് സർ, ക്ലിയർ ആണ്.
These are some of the methods you can use in these high prone areas, landslide prone areas. You can use this. There are more. I had that slide with me, but I'm not. You see this one? Anu teacher, you are seeing this? Hello?
sir, കാണുന്നുണ്ട്.
These retaining walls, I have shown you that low impact design in flood areas. Likewise, retaining walls, gabion walls, soil nailing, rock bolting, terracing and benching. These are the structural measures that you can adopt. Structural measures that you can adopt in the wired mesh, concrete walls. Nowadays, we have seen, no, in this express highway from Panvel to Kanyakumari, I think. From Panvel to Kanyakumari, is it? Panvel to Kanyakumari, there is an express highway. So we all are part of it, and you can see that these kind of roads, wherein they have used these concrete walls and then wired mesh and geotextiles, retaining walls. You see, you can see this retaining walls, terrace farming, and anchored mesh systems. These are some of the wherein the wire rope will be there, base plate and steel, all those things will be there, no? This will be rock bolting, all those things, gabion walls. So these are the structural measures that you can adopt in the in your what to say, landslide prone areas. So I have shown both. Okay. So these are the some of the softwares you can use. The open source softwares, yes, like QGIS. Is it visible, Anu teacher? Hello.
Yes, sir.
Yeah, these are some of the softwares you can use. This QGIS, ArcGIS, Erdas Imagine. Those are ArcGIS and Erdas Imagines are paid softwares. NB also paid softwares are recently bought from one of my project. And Ilvis is the free software. And nowadays everyone is into Google Earth Engine. Those are the softwares used. And these are some of the data browsing sites that you can use: Earth Explorer, NRSC, space imaging, digital globe. So this is SciHub, all those things you can use. Okay. And then learning platforms are there nowadays. Information is free. IERS, we have a very good facilitation. Indian Institute of Remote Sensing in Southeast Asia, this is the big gun. Indian Institute of Remote Sensing, ISRO, they are giving information through EduSat programs. They are giving hands-on training, offline sessions, online sessions. Okay. NASA, ARS, RSET, and yes, European Space Agency, Earth Observation, European Space Agency, Coursera, OpenLearn, FutureLearn, JUS. These are the different learning platforms that you can use. Okay. So that's much, ma'am. This is different presentation for different audience. Okay, thank you.
Thank you, sir. Now, participants, if you have any doubt, you can ask. Your mic will be unmuted now.
Hello, sir. Hello.
Ma'am, you
Hello.
can ask. We can hear you.
Hello, sir. So you have explained about the landslides and GIS, how we can
Hello, Parayu.
use the GIS for warning systems. So is it possible for us to use the real-time monitoring of GIS for warning the landslides?
Real-time monitoring. See, these are what I said was not on real time. This is, we can through our see, once this happened, okay, one occurrence was there. So we are using these at that location. What were the factors contributed to, or what are the susceptibility, or these? See, for example, if I am making a flood susceptibility zone, you can make nowadays, no, disaster reduction. The concept disaster, the prime minister 10 point agenda is there, wherein the disaster reduction is the, we cannot stop disasters. See, we cannot mitigate, but we cannot the disaster risk impact, the risk reduction can be done, taken. If you are aware of that particular, if you are giving this susceptibility map, in this particular area, you should not do any construction work. Okay, you should not do, you should not allow. If the local self-government group, all those things, local self-government or municipalities or wherever in the corporations, whichever the administrative capacity in the state level or the national level, they are telling you you should have what kind of, and wherever possible, you have to go for, in the case of flood and all, web designs, and the time possible. It's possible. It doesn't mean that if it's happening and if you are just informing what is the you have to reduce the casualty, you have to reduce the mortality. You are using this information. The main thing is we should be aware what's happening in and around, and what are the mitigation strategies that you can adopt. That's why I've shown you.
I think some network issue is there. Sir, are you audible?
ഡിസ് ചെയ്തോ?
ഓക്കെ ചോദിക്കും.
ഇത് ഡിസ്സാക്കിയോ?
ഇല്ല അത് ഓട്ടോമാറ്റിക് കട്ട് ചെയ്യാം.
സർ, ഇടയ്ക്ക് വെച്ച് വോയിസ് ബ്രേക്ക് ആയിരുന്നു.
നീ ഡിസ്സായതാ ഉണ്ടാവും. ഹലോ, ഇപ്പൊ കേൾക്കുന്നോ?
കേൾക്കുന്നുണ്ട്.
ഇവിടെ പവറിന്റെ ഒരു ഇഷ്യൂ ഉണ്ടായിരുന്നേ, അതാണ് ഒരു മഴയില്. ഓക്കെ, അത് വൈഫൈ കട്ടാകാം. അപ്പൊ ഞാൻ പറഞ്ഞതെന്ന് വെച്ചാല്, അതായത് ദീസ് കൈൻഡ് ഓഫ് മീൻസ് ത്രൂ ദിസ് സസെപ്റ്റിബിലിറ്റി മാപ്പ് ആൻഡ് ഓൾ, ഫ്ലഡ് സസെപ്റ്റിബിലിറ്റി മാപ്പ് through HP or frequency ratio method or whatever with the machine learning algorithms, you cannot stop disasters. We are downloading the data sets only, whichever data means already happened. See, if you want to give the real time this thing, you have to the current dynamic, it should be dynamic. Now the information should be, the satellite is, that is possible or not, it is possible, but the main thing is through these susceptibility maps, flood susceptibility maps and landslide susceptibility maps, you can tell that these are the areas we are susceptible to landslides, these are the areas susceptible to flood. So if you are giving permission to one building or home or house or buildings or road or whatever, whichever be the constructions, you have to use this information and you have to rehabilitate wherever the susceptible area. It will be very difficult to rehabilitate the people from this susceptible zone to some other areas. So it is, they will not, they usually they won't allow, because they don't want to leave their native place. So those kind of issues, this human resource management, all those things are there. But still, because I was earlier in forest department as forest range officer, I know in back the field level for implementing this policy and all those things, no, the tribal the rehabilitation, all those things. So this says this issue, but this whatever I told you was, these are the susceptible, you can make this see from the I have shown you the flood data which happened in 2018 2019, but I told you that because from that we got very good through validation also, it's good, it was very good. So you can tell that these are the areas you should not make any means encroachment. You should not you should not make construct buildings in the riverine side. Okay, റീസെന്റ് നമ്മൾ എറണാകുളത്തൊക്കെ തകർത്തില്ലേ, ആ സ്ഥലത്തിന്റെ പേര് ഞാൻ പറഞ്ഞു, മരട്. അപ്പൊ അങ്ങനെയൊക്കെയുള്ള you should not make any encourage any constructions on the nearby rivers or the water bodies. You should respect nature, then nature will respect back to you. That's my okay. Through information, through
Okay,
knowledge.
thank you.
Yeah.
Hello, sir.
Yeah.
Actually, in the presentation, the 4 different factors weightages were given for different
Yeah.
factors.
Ah.
So how we can justify scientifically that weightage is given based on what criteria?
That's why I told you, this AHP method, AHP analytical hierarchical process, which is been developed by SATI, which has been widely used in different disciplines. YouTube related. E-light of the method related. 1 second. Hello. Yeah, unlike I told this AHP method, unlike yeah, in AHP method, what you are doing is you have different stakeholders. For example, uh, if landslide happens in a vegetated area or forested area or the Idiki, there will be LSGD, local self government. There will be means dependent community whoever is residing there. There will be panchayats, there will be forest department, there will be irrigation department, there will be soil department, there will be scientists, KSDMA, there will be National Disaster Management Authority, there will be experts exclusively working on this scientific publications through publications, literature review, through literature review of the Western Ghats area. You can came to know that these are the facts and your experience and your field experience. Moreover, your field experience, you should go there. You through ground truthing also. Through this only you are doing this HP. It is not an easy go. But in for this training purpose and all, we are telling that the HP through simply we are for 1 week training and all. We used to tell that you just check the review literature in our place in Kerala or Kerala nearby area, whatever happened, so and so. So which factors they have given in landslide studies, we are giving that, we are adopting that. So to some extent, that justification is there. So scientifically only HP is a very good method, and frequency ratio also through experience only. See the machine learning approach, you are having the beauty of n number of data sets you can use that, and through different neural networks, through artificial this intelligence, you can do wonders in more predicting the models. So in HP and all, the weightage ഈ സ്ലൈഡ് കാണുന്നുണ്ടോ സാറേ?
വിസിബിൾ അല്ല സാർ. സാർ അത് പ്രസന്റ് സ്റ്റാർട്ട് ഷെയർ കൊടുക്കേണ്ടി വരും.
ഇടയിൽ കറണ്ട് പോയപ്പോ വീണ്ടും പോയെന്ന് തോന്നുന്നു.
അപ്പൊ വിസിബിൾ ആണ് സാർ.
See, these are the factors you are talking about, no? For example, this is another presentation.
Yes.
Yeah, we are getting information from DEM, LULC, and different through our general knowledge. I told you from your experience, from your so far knowledge, you know that low elevated area are prone to flood, right? Low elevated area are prone to flood, right?
Yes.
Yeah, so we are giving more weightage. I have shown you the both the case studies, Kozhikode district as well as Alappuzha district. In Alappuzha district, more weightage was given to elevation.
Right.
Yeah, because it is low elevated area, so elevation is having more importance for the so likewise only we are doing. So through our experience, through scientist consultation, one-to-one survey, focal group discussions with experts like you people, all those the scientists behind it, and then only we can the more the HP is the HP is better. You can weight, give the among this weighted among this different. This is only for training purpose. This is not the entire picture. The more the parameters you are taking, the more will be the precision. So different factors you are taking in, and then this HP calculator is done, and then the vulnerability weighted overlay analysis we are doing through softwares like I used to do in ArcGIS. I don't know about QGIS. I used to do in ArcGIS 10.4.1. So QGIS it's possible. I hope you understand. Means I cleared your question.
Yes, sir. Yes. Thank you. Thank you. Ramesh.
Thank you. Thank you.
Okay, sir. Moving on. Now I invite Roshni T. Mohan for providing vote of thanks.
Hello. Okay,
ma'am.
good afternoon all. So now we have come to the most interesting session. So on behalf of the Civil Engineering Department and the Sripati Institute of Management Technology, I sincerely thank Dr. Srinivasan for the informative session on the geospatial application in flood and landslide susceptibility mapping. Your valuable insights and practical knowledge have helped us better understand and the role of geospatial techniques in disaster management. Thank you for sharing your expertise and making this session engaging and useful for all of us. We are grateful for your time and contribution. Thank you, sir. Thank you very much.
Yeah, thank you. Thank you. Thank you, sir. Thank you for giving this opportunity. Hello.
Yes, sir. We can hear you.
Yeah, thank you. Thank you very much. Thank you. Thank you, ma'am.
Thank you, sir. Thank you, sir.
Okay, okay. So shall I off?
So you can leave participants.
Okay.
Feedback form will be provided in the chat box session. Please complete it. And also in the WhatsApp group also it will be shared. The next
I
session.
hope means most of the I hope I got questions from faculty only. Students, no questions.
Sir, this session is for faculty development program. So mainly faculties are.
Okay, okay. Mainly faculties. Okay, 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 okay. Thank you, thank you.
Okay. So participants, next session will commence on 2 p.m. The same link will be provided. Please join at the same time. Thank you for joining us. And thank you.
Thank you, Anu madam. Thank you, Srikanth sir. Okay, Roshni
Thank you.
madam. Okay.